So this video is about approximating the area under a curve on a graph. So here's a graph right here, and basically what I mean by that is for this particular graph we'd be trying to find the area under this curve, this f of x, which is 2x squared minus x plus 3, between 2 and 4. So that's the area we're trying to find. The way we do this is by drawing rectangles underneath the curve. We basically add the areas of all the rectangles, and this should give us an approximation of the area under the curve. The rectangles all have to have the same width in order to do this, and this width is considered as your delta x, the change in your x values with each rectangle. So here's what I mean by that. If we draw a rectangle right here, let's say that goes to 2.5, and then another one here at 3, and then another one here at 3.5, and then here's our last rectangle here at 4. So basically our delta x here would be a half, because each time the difference between each rectangle, the width of each rectangle, is a half. So the way we find our delta x when we don't have it drawn out for us like this is through this equation here, which is b minus a over n. B and A are the x values of the endpoints of the area you were trying to find. So in this case, our B would be 4 and our A would be 2. N is the number of rectangles you have. So just to show you how this equation works, if we take 4 minus 2, B minus A, we get 2. 2 divided by N is going to be actually 2 divided by 4, because we have 4 rectangles here. And 2 divided by 4 is a half. And as we determined before from this diagram here, our delta x, our change in our x values between the rectangles, is a half. So that's how this equation works. So basically, when dealing with approximating area under a curve, there are 3 different equations that will help us approximate it. And this is where summations come into play. So first we have the right endpoint formula, which is right here. This formula basically considers it so that the right corners of your rectangles that you've drawn end on the line of the function. So here actually what I drew before is an example of right endpoint formula, because the right corners, the right endpoints of the rectangles end on the function. Then we have left endpoint formula. In left endpoint formula, this is where we consider the left corner of the rectangle to be touching the function. So I'll draw that out quickly here. Just erase these. And so left endpoint formula, it would be so that the left corners, the left endpoints of our rectangles are touching the function, like this. So that is the difference between left endpoint and right endpoint. And as you can see, the formulas are different, but they both work to solve. And again, with both of them, with all 3 of these actually, we'll get into the midpoint formula soon. Again, you're just going to take your n value, the number of your rectangles, you're going to plug in your a value, and with the summation, you will be able to determine an approximation of the area. Because you're basically adding up, what the summation means is you're basically adding up the areas of all the rectangles. Multiplying it by your delta x. So, before you get into these formulas, you need to find your delta x. Anyways, here is our midpoint formula. And this is where the middle of the rectangle is on the line of the function. So again, I'll draw that quickly, an example. So yeah, the middle of the rectangle ends on the line of the function. So here's an example. Again, the middle is on the function. And there it is. So that would be an example of when you use using the midpoint formula. The middles of your rectangles are on your function. So all 3 of these formulas work. Now we'll get into an example problem down below using one of these formulas to help approximate the area. So here's our example problem. It's basically asking us to calculate R3 for f of x equals x squared minus x plus 4 over the interval 1, 4. So we're going to be using our right endpoint formula here because it's asking for R3. And so first of all, what we should do is find our delta x. And we can use that using b minus a over n. So our b value is here. It's 4. That is the endpoint of the area we're trying to find. So we have 4, and then our a value is 1, so it's minus 1, over n, and our n in this case is 3, because what this 3 here means is we have 3 rectangles, basically means n is 3. So 4 minus 1 over 3, which equals 3 over 3, which equals 1. So our delta x is 1, which actually makes this a lot easier to work with. So our R3 formula, R3 equals delta x, sigma, and then our n is 3, I equals 1 down here, and then it's f of 1 plus I delta x. And we know our delta x now is 1, so this we can ignore because it's multiplication. So then we end up with sigma n equals 3, I equals 1, and then f of 1 plus I delta x, this just becomes I because delta x again is 1. So we're going to plug this whole thing in as our x into our function. So our function is x squared minus x plus 4. So we'll end up with 1 plus I squared minus 1 plus I plus 4. So that's what we end up with. And so we should work that out first of all. We should expand that out. So we will end up with this sigma equals 1, and then I plus 1 squared is going to give us I squared plus 2I plus 1. Then we should distribute the negative here, so then we have minus 1 minus I plus 4. So if we work that all out and simplify it and combine terms, we'll end up with sigma again, n equals 3. We'll end up with I squared plus I, and then the 1's cancel, so we just have plus 4. So I squared plus I plus 4 is what we're left with here. So now what we're going to do, we're going to use our properties of summations, and we're going to split this up into 3 summations, because we can do that, because they are 3 terms added together. So we're going to make it equal to 3 different summations with the same n value and stuff. So I squared plus now the summation of I plus the summation of 4. So now again we can use our properties of summations. This here is a summation of a constant 4, so it will just equal the constant times n. So it will be 4 times 3. And then these two here are our power sums with an n value of 3. So I squared, our power sum, is n times n plus 1 times 2n plus 1 over 6. So we'll write it as 3 times 3 plus 1 times 2 times 3 plus 1 divided by 6. And then this is another power sum with just a variable I, and that will be n times n plus 1 times so this will be, this right here will use our power sum, and it will be n times n plus 1 divided by 2. So it would be 3 times 3 plus 1 over 2, because again n is 3. And then this is a constant again, so it's plus 12, because 4 times 3 is 12. So there you have it. Then we should just work this out. And this will end up being 3 times 4 times 7 divided by 6, which equals 14. This will end up being 3 times 4 divided by 2, which is 12. And then we add a little bit of an error there. So this will actually be 6, because 3 times 4 divided by 2 is 6. So slight error, but so it's plus 6, and this is 12 plus 12. So it equals 32. So that is the approximation of our area using our right endpoint formula. So as you can see, it's not too difficult. You simply plug in your values for a, n, etc. Find your delta x.